All right, let's look at this problem called unique paths. Let's have a read. There's a robot on an M cross N grid. The robot is initially located at the top left corner. Robot tries to move to the bottom right corner. The robot can only move either down or right at any point in time. Given the two integers M and N, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to something. Okay, so from start to finish, at any point you have two options. You either move to the right or you move to the bottom, and you have to reach the finish line. All right, let's look at this example on a whiteboard maybe. So one of the examples that is given is a 3 cross 2 grid. So 3 cross 2 grid means you have just two here and three rows like that. You are here and you want to reach here. So the different ways that are there is one way is you take this path, other way is you take this path, and there is another way wherein you do this and then this and then this, right? So these are the three different paths. Now essentially, let's call it ways. So I have to reach, let's call it m, and even though yeah it's a zero base and it will be mi, but so basically the number of ways to reach this point. So I'll either reach from this or I'll either reach from this. So number of ways to reach mn equals to the number of ways to reach one left, actually one top guy, so m minus 1n, and or you come from the left side, which is the same row but the previous column, right? And I think we can solve this recursively or through a DP and get the answer that way, right? So what are the edge cases or the base conditions? Well, one of the things is if you look at the grid and you, whatever your grid is, the first row, right? If you're here, how no, there are number of ways to reach here is just one. You can only reach this way because you cannot go up, right? Similarly, so all of these number of ways to reach any of these points is just moving right, right, right. Similarly, for all of the first column, the number of ways to reach this or this or this, all of this is just this. So all of these highlighted ones are just one, right? And all others can be populated based on this. So 1 plus 1, 2, and then 2 plus 1, 3, and so on. And you can populate and get the answer for this guy. So let's build the solution based on this. So we define an array called ways of length of the same size as this mn. And what you do is we know that the first row so is all one. So first row I can populate simply as arrays dot fill. The first row I can just call this, right, with 1, and the first column I can also set to 1, which is so int j equals to 0, the columns are row, so int I equals to 0, I is less than m, and I plus plus. I can do ways of I, and 0th column is also 1. So I initialize my array, the ways matrix with 1 in the first row in the first column, and then for subsequent ones I just populate. So I equals to 1, I less than m, I plus plus, and j equals to 1, j less than m, j plus plus, and you go, okay, the number of ways to reach ij is the same as the number of ways to reach I minus 1j and the number of ways to reach ij minus 1, right? Because that's the only two ways that you can reach ij. And so at the end, you return ways of m minus 1 and n minus 1. Okay, let's sum it. Compilation error. I equals to 0, I less than m, I plus plus. What does it say? Cannot find symbol. Okay, so and submit. Okay, so this works. Now coming back, let's talk about the time and space complexity here, right? So the time complexity here basically is O of m cross n, right? We are going through each and every element in the array. And the same is the space complexity as well, because we create an auxiliary array for the phase, and it is also of m cross n. Now, let's think about it a little bit more. Can we improve it further in terms of the space complexity? If you think about it, for any guy, I'm only interested in just two elements. I'm interested in the row previous, and I'm interested in the just the previous guy. So coming back to a whiteboard for a minute. So when I'm populating this guy, I only need this guy and this guy, right? All the previous rows I don't really need. So at any point when I'm filling up this row, I only need the previous row, right? So I only need two rows at max. I don't need the previous rows, right? So can we optimize it further? So instead of keeping a full m cross n array, can I just keep maybe two rows, right? This will be my initial row and or the previous row, and I'll this will be my current row, and I'll populate this current row based on the previous row, and then I'll make this current row as my previous row for the next guy, right? So I don't keep a full space, but I'll keep switching the previous, and that way I only maintain like a single row. And that will reduce the time complexity to, instead of being from m cross n, it will change to like 2 cross, and so essentially it will just become O of n. Let's change the code to do that. So instead of using this m cross n, I'll just keep like a single row ways to begin with, and I will initialize it to this, and I will obviously the first time around, the first row is all the number of ways to reach is 1, which is all good. And now here what I'll do is for every subsequent row, I will create like a, so this is my previous, so for every subsequent row, Ways is my previous row, right? So this I'll make like a new, again, a new, uh, call it current row Ways, right? And we'll set this to, again, new int of n. And again, the first column, so current row Ways, the first column is always just one, like number of ways to reach is one. And so now I'll change this to, hey, so now I'm populating my current row Ways, and current row Ways for j equals to current row Ways. So firstly, yeah, the previous guy in the same row, so the current row Ways of j minus 1, and the previous row was Ways, and I'm gonna go the same index j, right? And at the end of this, I can do is this, hey, once I populate the current row, now this make this current row as the previous row. So Ways equals to current row Ways. All right. So that's, in that way we only have to have two rows at max, right? And yeah, so let's submit this. And obviously some compilation error. Yeah, so it will just be now, this Ways will now represent the last row, and for the last row, the last column. So, and this works as well. Now, I want to also talk about, there is another way to solve this problem without using even DP, without using any space at all. So right now, we reduced this from O of M, that's time complexity is this, right? And the space complexity of our initial solution was M cross N, and we changed it to O of N. Now, there is another way where you can solve this by using O of 1 space. And let's talk about that approach as well. So essentially, if you think about it, what's happening is You are here and you want to reach here, and the way to reach here would be you are traversing these many downs and you are traversing these many rights, right? So essentially, whatever answer that you get to reach here would combine uh, m downs and n rights, right? That's what you want to do. So it sort of translates to a permutation problem if you think about it, where if somebody says, "Hey, I have m apples and n oranges," how many different ways I can arrange them, and that combination comes to, hey, total divided by m factorial. So using the same math, we can use the same math here, and we can find out the number of d's and number of r's, and then we can do, hey, it's just r plus d factorial divided by r factorial d factorial. And if you look at it, this is just essentially r plus dcr or r plus dc d, right? Whichever. So that's what it translates to. So what we will do is we'll convert this problem into an NCR problem, right? Where n equals to the total number of the total steps, and total steps is m minus 1 plus n minus 1. These are the total steps, right? And r equals to m minus 1, right? Like one of those, either of those, or n minus 1, whichever you want, right? And then you solve for NCR. Now, how do you solve for NCR? So let's take an example of 10C8, right? So obviously, if you can also convert it into 10C2, right? Because same thing. So this becomes 10 9 by 1 2. So one of the things to note is if I'm solving 10C8, I might do something like 10 9 8 7 6 5 4 3, I don't know, right? And 1 2 3 4 5 6 7 8, something like that. So instead, I do this. So one of the things is r if r is greater than n minus r, then you so yeah, if you're finding NCR, and if r is greater than n minus r, then instead solve for NC n minus r. Basically, keep the r as a smaller one, right? That's one thing. So I use this, and here I wanna I wanna ensure that I can divide things. So, for example, 10 can be divided by 2, right? So I'll change this. So I'll do this as 9 10 by 1 2. So both numerator and denominator in increasing orders. So what that would mean is that if I'm doing NCR, I'll do 1 2 3 up and so on till R. And what will be the first guy here? So if you look at, in this case, it was 10 minus 2, which is 8 plus 1. So this would be n minus r plus 1, and then this would be n minus r plus 2, and up till and so on till finally you will reach n, right? So this is how we'll try and solve for NCR. So let's do this and use this approach in the code as well. So now this was one way, and we reset the code and we say, hey, I want to do NCR. So return total equals to m minus 1 plus n minus 1, right? So I'll call, hey, return NCR, where I goes total and I return any one of them, right? M minus 1, let's say. And now I have to just solve for int NCR, where this is n and this is r. And like I said, I want r to be the smaller one. So if r is less than, sorry, if r is greater than n minus r, Then let's return that. So ncr and n minus r. So this guarantees that r is quite small. So now I know that my denominator, so let's define result as 1. Now I starts from 1 and I goes till r and I plus plus, and we say result equals to result times, so you are multiplying by n minus r plus I, and you divide it by I. So this is what you multiply, and then you divide by I. And now obviously this multiplication can become big and it might exceed few things. So let's do this instead of int, just call it long. And then when you are returning, convert maybe to int and return result. Okay, let's see if this works. And this works as well. And so finally, with this approach, we can see the time complexity again is the loop that you are running, first of all, is just going till the smallest of r, right? So of this approach, the time complexity really is O of min of m comma n, right? And the space complexity, this is time, and the space complexity is O of 1. All right.